In this problem, they give us this number, 1a, 2b, 6, where a and b are digits. And they tell us that it's evenly divisible by 12. Now, if it's divisible by 12, that means that it's divisible by 4, and it's divisible by 3. Now, there are two different ways to tell if a number is divisible by 4 as opposed to divisible by 3. Now, if a number is divisible by 4, then that means the last two numbers are divisible by 4. That's how you can tell. But if a number is divisible by 3, what that means is that you can add up all the numbers and they will be divisible by 3. Now, we know some of the numbers, just not all of them. So what would we get if we added up all the numbers? So 1 plus a plus 2 plus b plus 6. So if we add up the numbers, we get 1 plus 2 plus 6 is 9 plus a plus b. Now this whole thing has to be divisible by 3, but notice that 9 is divisible by 3. So in order for this whole quantity to be divisible by 3, that means these two have to be divisible by 3. And this is kind of the key for us right there. Is that, all right, if a plus b has to be divisible by 3. So what we do is we do this in a very ordered way. So we start with a equaling 0. Now if a has to equal 0, then the question is, well, what can b equal? Well, these two added together have to be divisible by 3. So b could be 0, b could be 3, b could be 6, or b could be 9. All right. Now, let's write this out. 10206, 10236, 10266, 10296. So, these four numbers are indeed divisible by 3. But then the question is, are they divisible by 4? Because we've been spending time talking about divisible by 3, but how do we know if they're divisible by 4? Well, we got to look at the last two digits. Is this divisible by 4? No. Is this one divisible by 4? Yup. Is this one divisible by 4? Nope. Is this one divisible by 4? Yup. So here we've got two possibilities here. So now what we have to do is now we have to look through all the different numbers. So if a equals 1, then what is b? Then b has to equal, well, has to be divisible by 3. So 2, 5, and 8. All right, so we have 102, sorry, 11226, 11256, 11286. So we have these three possibilities. So now, which of these are divisible by 4? 26? No. 56? Yes. 86? No. All right. So now let's look at a equals 2. So if a is 2, that means b is 1 or 4 or 7. And yeah, those are our our options. So let's see. We've got 1, 1, 1, 2, 2, 1, 6, 1, 2, 2, 4, 6, 1, 2, 2, 7, 6. So looking at these, looking at the last two digits, that's divisible by 4, that's not, and this is. Now it seems like this video is going to go on for a while, but it's actually not, because here's why. If we look at a equals 3, what is b going to equal? Well, b is going to equal 0, 3, 6, 9. It's actually going to be the same as the ones up above. So, if I write these numbers out, I get 1, 3, 2, 0, 6, 1, 3, 2, 3, 6, 1, 3, 2, 6, 6, 1, 3, 2, 9, 6. Well, this is just testing the same thing we did up there. 06, 06, 36, 36, 66, 66, 96, 96. So what we're on this cycle. So when A was 0, we got 2. When A was 1, we got 2. When A was 2, we got, oops, that should be a 1. A was 2, we got 2. So when A is 3, we're again going to get 2. So what happens is we can just say, well, 3, when A equals 3, that's just a repetition of when A equals 0. So this will be when A equals 4 and 5, and 6, 7, 8, and 9. So if we add this out, so if I just cross this out and say, well, this is the same when A is 3, 4, 5, 6, 7, 8, 9. So 2 plus 1 plus 2 for 1, 2, and 3. So 2 plus 1 plus 2 for 1, 2, for 0, 1, and 2. And then for my next cycle, for 3, 4, and 5, 2, 1, and 2. 2 plus 1 plus 2. And then for one more cycle, for 6, 7, and 8. So 2 plus 1 plus 2. And then, not a whole cycle, but we add 9. So we add 2 more to that. And when we do that, we get 17. So there are 17 numbers that are evenly divisible by 12. So there's our answer, and we're done.